Good morning. My name is Hui Song from Sintef, Norway. I'm glad to take this opportunity to share with you our initial thought and ideas about a new concept called computing fleet as a way to ease the managing of microservice-based applications on the computing continuum. For those of you working in Europe, you have probably heard the word computing continuum in different occasions. I have no problem about the choice of wording since I'm not a native English speaker. But I can try to tell you what I understand the meaning behind a computing continuum. The idea is extension of cloud computing. In cloud, you don't want to directly handle all those physical computing nodes that you can have from data center. Therefore, the data center owners just provide virtual machines so you can use those services as if they are from one single entity instead of many complex nodes in the data center. And now as the data volume changing dramatically, it's not always feasible to send all the data to the central cloud. And in some other occasions, you need very low latency, so it's also not possible to wait for the data to come to the cloud and back all the way back. Therefore, edge devices like gateways or local machines or even some microcontrollers are more and more used together with the central cloud. And they call this the continuum from cloud to edge to the IoT. The same question comes again. If you have all these choices and all these devices and nodes together, you still want to use them together as a single entity. But then how? In cloud, this is done by the concept of cluster. But and also now there are research approaches and open source tools try to consider all those edge devices together as an edge cluster. But there's a fundamental difference. In cloud or in a data center, all the nodes are almost the same. They are replaceable to each other and they can use in the same way. But this is not the case for edge. You have different types of devices and they are distributed in different locations and they're dynamic. So we need a new concept. That's the thing we call this concept the fleet. So fleet is the new cluster in the continuum. Same as a cluster, it's a group of entities that are used together as a whole single system. They are autonomous and they coordinated with each other. But differentiate from a cluster. In the fleet, all the devices are unique. They are heterogeneous, which means they have different hardware architecture sometimes, and they have different capacities. At the same time, they're dynamic. Devices keep joining and exiting the fleet continuously. And also they are changing their context and profiles. And last but not least, all these devices plays different roles in the fleet. So the idea comes from the word fleet in the Navy. So you have different types of vessels. They have different roles in the battlefield, but they are commanded together as a whole system, a whole fleet. Now the question comes, how can we use all these heterogeneous and dynamic devices together as a whole single entity? And this is what our reference architecture for fleet computing tries to solve, or at least to try to figure out what are the challenges and how to solve these challenges. So come up with 3 layers. The lowest layer is what is called the fleet infrastructure. You have the devices. The first thing you need is to know as an owner what devices actually have, what are their profiles, what are are their roles in the system, and if they are currently alive or offline. We use the concept, what we call device twins, as a virtual representation of all the devices, so you can get to know them from an overall global view. On top of it is the software layer. Considering the distributed nature of all these devices in the fleet, it's a natural choice to use microservices as the architecture of the applications. So every application is a group of microservices connected with each other, and each microservice may have multiple instances distributed into different devices. And on top of the microservices, there's the data layer. So you see the data flowing through all these microservices, but now you don't care actually about the function role of the microservice, but more about their position in the whole data flow. The diagram on the right shows the same architecture from a user's point of view. So if you are a fleet owner, what you have in the very low end are a bunch of devices connected to each other. And with the infrastructure layer, what you get is a device twin representing all these devices and some virtual resources that you can provide to the upper layers. On top of these these virtual resources, you have the application comprising multiple microservices, and you see the dependencies between those microservices. And on top of it, you see where the data is from, how the data flows through the microservices, and where they goes. All the three layers are different when comparing handling fleet comparing to handling the cluster in the cloud. Due to the time limit, we don't have time to go through all the layers, but we zoom in into the microservice layer since we think this is the most representative. The challenge in the application layer comparing to cloud is the heterogeneity and the dynamicity of devices in the fleet. Heterogeneity means that the devices like gateways or IoT sensors, they are different from each other. They have different hardware architecture and different complexity. So sometimes they need different versions of services, even if they have the same function, but they have to be either implemented in different way or configured in different way. And dynamicity means that these devices are not always the same. They're not just sitting there waiting for the deployment. They may be offline. Some of them may be offline. Some of them may change their profile or the role in the whole fleet. Or some may be used by different users, so therefore they need a different version of the software. And this raises the question for both deployment and orchestration of the services on these heterogeneous and dynamic devices. So we come up with the idea first that orchestration has to be in the reverse way. So instead of using a central node to orchestrate all the microservices in application to the devices, it has to be the other way around. The device, the central node or the central coordinator can simply note that what version of microservices can be deployed or should be deployed on all the devices in the fleet. And it has to be the fleet itself to actually get the data and get the data about what microservices need and actually deploy the microservices. So we come up with two solutions for this. One is about the high-level orchestration, and the other is about the deployment coming from the lower level on the devices. We don't have time to go through all the other layers, but we can quickly show the whole idea based on software prototypes and a preliminary evaluation scenario. The scenario is based on an application called remote patient monitoring. In the photo, you can see the basic setup of one patient at home. They have the medical gateway in the middle, and this black box connects to several different medical devices via Bluetooth. It collects the data about you as a patient in a regular pace and record the data and send it to the cloud as a patient journal. In this system, we need to update the software to collecting data or to interact with different patients in a regular pace. And in this way, we need to update and redeploy the application regularly. Here we implemented this based on a solution from two layers. In the infrastructure layer, we use Azure IoT Edge as a commercial tool for fleet management, and on the application layer, we use two software we developed ourselves on orchestration and deployment. The sample scenario is based on an example to update the access control software. The company want to roll out a new way to access for the patient to give the access right to their doctors through a button that is connected to the gateway. To do this, we need to update the software so the developer can start developing the function and together with it provide some deployment notions. So which device can host the new version of software, which can't. And this is obviously depending on whether the device has a button attached to it or not. After that, but at this stage, the developer doesn't need to know what devices are there, which has a button, which are not. He or she can just deploy the whole, all the different versions or different variants of the software together into the fleet. And the orchestration tool will figure out which device can host a new version, which can not, and therefore has to keep using the old one. And this is recorded on the central repository. In this example, we have selected two devices, one with a button and one without. When the two devices are online, the deployment engine on the devices will get contact with the central node to see what version of the software it has to be deployed and trigger the deployment processes. And in the end, you will see that only the devices with the button are updated. All the others are not. The ones without button keep using the old version, and the one that is not online will not be updated at the moment, but they will catch up when they are online again, as it does on this sample device. So this shows how the fleet deployment and orchestration handle the problem of heterogeneity and dynamics. So that's all I can say within 10 or 15 minutes. So if I have interest to see the whole story, we have some publications and we also have our code base. So you're welcome to have a look, and any comments will be more than welcome. So that's it. Quick summary. We introduced a new concept, fleet, as the cluster for the continuum, and we have a reference architecture. We try to figuring out what are the challenges and how to solve them by software platforms. And we have shown a quick example as a proof of concept of 2 layers with a use case showing up the tools that we developed for the software layer. So that's it. Thank you, and any questions or comments, please.